S is inversely proportional to the cube of t. So we write that as S is inversely proportional to the cube of t. And it says in the question that S equals 4 when t equals 3. So the first bit asks you to write a formula connecting S and t. So we rewrite this as an equation, placing the proportionality sign with equals k. We then substitute these values in. So we have 4 equals k over 3 cubed. We rearrange to find k. That divide by 3 cubed, because of this tide, becomes times 3 cubed. So 4 times 3 cubed. 3 cubed is 27. And 4 times 27 is 108. So that gives the value of k equals 108. So we rewrite the equation as S equals 108 over t cubed. That's part A. For part B, we use this equation we've got here. So we use this equation to answer the next two parts. So part B says use the formula to find the value of S when t equals 5. So the value of S when t equals 5 becomes 108 over 5 cubed is 125. And using a calculator, 108 divided by 125 equals 0.864. It's not a whole number, it sometimes won't be. So part C then, use your formula to find the value of t when S equals 5. So now, we've rewrite this equation for S equals 5 this time, equals 108 over t cubed. Now we need to rearrange the formula. So if we take this over that side first, to get rid of the fractions, and then put the value of 5 back over this side, gives us that equation. It's easier now to just work out this bit. So t cubed equals 21.6. And to find out what the value of t is, we can find the cube root of 21.6. So t equals cube root of 21.6. So on the calculator, cube root 21.6 gives us a value of 2.784953. Doesn't say to round it, so leave it as it is. For this question, we need to find an equation that connects the value of x and y in this table, as it says. Now to do that, we have to look and see what we've got. So we've got values of x and we have values of y. The value of x is 2, the value of x is 5 and 3. This is made a little bit difficult because they haven't made them all the same numerator. So what you could notice here, and what I told you isn't a hint in the lesson, is you change that 1 over 2 into the fraction 2 over 4. The 5 becomes 2 over 25, and the 3 is 2 over 9. So these two are in the table already. This one, I've just changed it so it's the same numerator as the others. Hopefully then once you've done that, you see that the 2 remains constant, but the denominator is changing. And if you can see the relationship between 2 and 4, 5 and 25, and 3 and 9, hopefully you realise this is 2 over 2 squared, 2 over 5 squared, and 2 over 3 squared. So an equation that connects x and y in this table, you could write that y equals the 2, which remains constant, over this value here squared. So this value is the x value squared. So we can write that as x squared. This here now is the equation that we're going to use in this question. So for part B, we need to use this equation here to find a value of p. So basically what we're trying to do is find the value of x when y equals 1 over 32. So use this equation and substitute this value of y into it. So my value of y is 1 over 32 equals, this side then is 2 over x squared. For the fractions, we don't like the fractions written out like this. We cross multiply. In this case, 1 times x squared is x squared. That 32 goes over that side and becomes 2 times 32. So x squared equals 64. To find the value of x, we simply square root both sides. So the square root of x squared is x, and square root of 64 is 8. So my value of p equals 8. This question, the difficulty with this question is the amount of words here. So it says about trapeze artists swinging from a long rope, the time t seconds to make one complete swing to and fro is proportional to the square root of the length. What we need from this is the important parts. The time, t, is proportional to the square root of the length, L. So we write an equation giving t in terms of L. So part A, first of all, we'll say what it says here, that the time t is proportional to the square root of L. So change the proportionality symbol to equals k, gives us that. We then use from the equation, from the question, that the length is 4 and the time is 4 seconds. So substitute these values in, we have t equals 4 when L equals 4. So 4 equals k times the square root of 4. So k equals 4 divided by the square root of 4, which is 4 divided by 2, which is 2. So we know our value of k, we know the constant, so we would rewrite this as t equals 2 root L. So this now is our equation we're going to use for the rest of the question. Part B. The trapeze artist now swings on a rope twice as long. Find the time taken to make one complete swing. So we know the length is 4, so it's going to be twice as long. So the length now is 2 times 4. So our length is 8. So our time, t, equals, using this equation here, 2 times the square root of 8. 2 times the square root of 8 equals 5.6585429. Just write everything down the calculator, and if you want to round it, 5.7 seconds to 1 dp, one decimal place. See, now it says it takes twice as long on another rope, so a new rope, so we don't know the length, but we know it's twice as long, so the time is twice as long, so the time is 2 times 4 seconds, so this times the time is 8 seconds. So using this equation, we write down 8 equals 2 root L, substitute our value in, and to solve it, square root of L equals 8 divided by 2. That 2 goes over there, becomes divided by. So the square root of L equals 4. To find out what the value of L is, you square both sides, because that's the inverse of square root. So L equals 4 squared. So L is 16 meters. For this question, again, reading the words, surface area of a sphere is proportional to the square of the radius. So we've got the radius, and it says in the question, the radius is R and the surface area is S. So first of all, writing those words using proportionality, we would say that the area of the sphere is proportional to the square of the radius. First part, A, asks us to write an equation. So we rewrite the proportionality symbol as equals K R squared. It says in the question that R equals 0.5 centimeters when S equals pi. Pi is just a number, you can use it like that. So we substitute these values in. Pi equals K times 0.5 squared. Rearranging gives us K equals pi over 0.5 squared. 0.5 squared equals, you can use a calculator for this if you want to, 0.25. Okay, at this point, K looks a bit confusing until you remember that dividing by 0.25, so dividing by 0.25 is equal to times 4. If you think of it this way, how many 0.25s are there in 1? There's 4 of them. So dividing by 0.25 is the same as timesing by 4, because each whole has 4 0.25s in it. So we write in the equation, we have S equals 4 pi times R squared. So now this is the equation we're going to use for the rest of the question. Part B. So for part B, the question says a tennis ball has a diameter of 6.8 centimeters. Find the surface area. So now we use this equation, we just substitute the values in. So the surface area equals 4 pi times 6.8 squared. So using a calculator, 4 pi times 6.8 squared gives me a value of S equals 581.0689772, or well, let's just say 581.1 centimeters squared. Part C, using the same equation, but this time it says the surface area is 1600 pi. Don't forget about that pi, which is part of the number. So that means that the surface area, S, is 1600 times by pi, and that equals 4 pi R squared. Because we have a pi on both sides of the equation, they will cancel out. Or, if you'd like to think about it, we're dividing both sides by pi, which again cancels them out. So this line becomes 1600 equals 4 R squared. To find out what R squared is, we divide 1600 by 4, which equals 400. Got a bit ahead of myself there. So R equals the square root of 400, because to get rid of the R squared, we square root it. So R equals 20 millimeters. And this time it's millimeters because the question was millimeters. This question says, look at the spring, it's stretched by a weight W. The extension E, so the extension of a spring is directly proportional to the force W. Okay, so first of all, as before, we need to write an equation. The first thing we're going to do is make the proportionality statement. The extension is proportional to the weight. We then replace the proportionality symbol with equals k. Now from the question, when w equals 3, the extension is 0.3. So w equals 3, the extension is 0.3. We put these values into the equation, substitute them into the equation. 0.3 equals k times 3. K then must equal 0.3 divided by 3, which is 0.1. So substitute the value back into the equation. E equals 0.1 w, or if you like, times by 0.1 is the same as divided by 10. That's easier to work with. So this here is the equation we're going to use for the rest of the questions. Part B. A weight is added to the unstretched spring, so there's no extension. The spring stretches from the 0.2 to 0.6. So first of all, if the spring has gone from 0.2 to 0.6, it's extended by 0.4 meters. So now we've got a value of E, we substitute it back into this equation. 0.4 equals W over 10. So the weight, or W, put that 10 over there, is 0.4 times 10. So the weight is 4 newtons. Part C, what weight would produce an extension of 8 centimeters? Well, because everything else has been in meters so far, let's change this to meters. 0.08 meters. And then substitute this value into the equation. So our extension of E is 0.08. So we write 0.08 equals W over 10. So W must be 0.08 times by 10, which is 0.8 newtons.